welcome to another episode of Microsoft Azure Community User Group. Today we have two amazing speakers talking about Azure AI and IoT. So before we get started, we're just going to do a quick housekeeping. Bear with me a minute. Let me just show my screen. Okay. Can you see? Yeah.
Yeah, all good.
Okay, cool. Yeah, so who are we? My name is Nicholas. I'm a current MVP and working as a senior platform engineer at Canis.
Hey folks, Kevin Green, Azure MVP, working for Ergo in Dublin. Welcome back to another episode of the Azure Community User Group.
Yeah, so as always, the code of conduct. So all members of the group should abide by the code of conduct. Be friendly, welcome to everyone, be patient, be thoughtful, be respectful, inclusive, be open and curious, and always try to ask questions to understand and not to criticize. Would you like to do this one?
Yeah, I'll do this one. So as Nick said, we've got two amazing speakers tonight. Topics are going to cover Azure AI and IoT in the context, IoT operations rather in the context of Azure. So we've got Manuel Sanchez Rodriguez, who is a director for Azure App Modernization at NTT Data. Manuel is a Microsoft MVP in Azure and also AI platform. Then we've got Damian Flynn, a long-term MVP Irish friend of mine, who is the Azure Practice Lead at Innofactor, making incredible technology incredibly simple. So I've given Innofactor a nice plug there, Damo. And Damian's session is going to be on introducing IoT operations. So Nick, next event, Nick, do you want to?
So the next event is next month, so it's not been confirmed yet. Still on the schedule. So keep an eye out on socials for that. So let's just do the first speaker with Emmanuel. He's talking about Azure AI. Let me just bring the speakers up. Yeah. So let me show you. Yeah, you want to share your screen? Oh yeah, got it. There you go. All right.
Perfect. Thank you.
So before we get started, would you like the question throw at you in the middle or at the end, Manuel?
I prefer in the end, maybe. Interactive session. So maybe have in the chat comment. You have interrupt me, no problem.
Okay. No, so the floor is yours, so you can take as much as you want.
Okay, perfect. Thank you so much. Thank you for the invitation, and I have the pleasure and I have the honor with this event. So, and a small presentation. You have a presentation with me. So, I'm Manuel Sanchez, and I head of the App Modernization and Entity Data UK and Ireland, and I'm Microsoft MVP. Yeah, the session today is explained with the Gen AI application in real use to organization, right? So it's the world is, as you have seen, technology is advancing very quickly. And the last year with the AI technology, so it's really, really impressed. So we know it's hard to build LLMs application, company want to build in solution, but how, right? So it's the new challenge, new models, what is exactly with the working together around of the AI. So maybe it's possible with debugging in local and production, right? Now there is the mystic solution, automate this better. I think it's we need the new tooling, right? We are going to the shoot of the tools, and I hope to make real in this session, right? So today we're exploring an exciting new frontier in AI, in agentic AI. This concept is transforming how we interact with technology, rather than simple automating tasks, agentic and representative intelligent agents that can handle more complex workflow and adapt to changing requirements and collaborate with the human to achieve better outcomes. This evolution paved the way more dynamics and efficient system, moving beyond the limitation of traditional automation, right? So the last month, I have more onions around the bill, and today is recollect the more onions and update with my slide. So, and in the concept with an AI agent to automate and execute business process and nearly autonomous, The AI agents can plan, adapt to the new information, and execute tasks independently, making them capability on the handling complex dynamic environment, decision making and autonomous action, and they can learn from feedback, right? So adjust the strategy, and you needn't operate with the minimal human oversight, right? So the most important is in the last few weeks, Satya in the keynote, right? So it's discovery with the new AI, the Azure AI Foundry platform, right? With the combination with the rest of the services around the Azure. So the as model evolve faster and become more capabilities with an example being dropped with that all time, right? So apps will evolve to become statefully, multi-model, multi-agent, and the most important is the scalability and production ready and agents and apps, right? So it's the need around of the AI app servers. What is the building, right? So Microsoft is proposal with the Azure AI Foundry, with the hub concentration, with the all capability as services. What do you need for create with the new production for intelligence, right? So the next thing, it's the create of the build agents and orchestrate them around the AI Foundry and agent services. So you have a possibility to create for the new lines. So today I have the more deep dive around of the semantic kernel, but I really like it this announce because you have an agent running, you need to come computer in time for them. So from serverless with Azure AI, using Azure functions, using Azure Container Apps, so extreme control how you scale with the Azure Kubernetes services, for example. And we are providing for the full spectrum of computer after you have the right pricing performance for any new agent scenario. So the most important with these onions is you are making it straightforward to connect Foundry to container apps and function. The most interesting, if you and deploy in any open source model of the catalog, right? So Lemma, you have a possibility with Grok or anything. You have a proposal or you own of your data with using your property LLM or your model. Deploying the Kubernetes service, whatever it is in the cloud or hybrid using Azure Arc, right? So it's really, really, really interesting. So in terms of the evolution of the LLMs, so in terms of the AI system involved, we are moving from narrow single task solution to more expansive interactive system in the early days. So you have the LLMs we're using for very specific tasks like summarizing document. Now we're seeing the more sophisticated architecture where AI can handle more complex tasks by interacting multiple data source, right? So it's a different structure around the solution around the AI. So for example, for the single agent solution to multi-agent system, we are looking the potential for AI to solve larger, more complicated problems, right? So I think it's the key enables is the 4 topics, right? So the human level reasoning capabilities is enable critical thinking, replanning to establish revolution strategy and incorporate human in the loop. The second is the large context windows. So it's the enable reasoning over execution history to replan plus integrate feedback for multiple agents. The 3 is SLM for specialized agents. For example, enable rapid execution to keep human engagement in the loop and enable cost efficiency resolution. The 4 is, I think, is the best scenario now is most optimized is multimodality support, right? So it's the width and scope of use case on the easiest accessibility for the agent AI system, right? So the agentic AI system follows certain design pattern that ensure they operate effectively and efficiently, right? So the common pattern include retrieval augmented generation is a traditional chat, and I think is the old people or the old men in the in the place. I think is a remember of the Microsoft Bot framework. So I think it's the RAG system is the bot plus plus, right? So it's the similitude. So which improve the quality of answer we use in the external knowledge, right? So with the in the RAG. Later is the external knowledge and the multi-agents, right, system, where specialized agents work together to tackle complex problem. Finally, this design partner are essential in building scalability and robust AI agent that can adapt to variety, to tasks and environment, right? So specifically for deep dive, okay, it's very quickly, it's only introduction because maybe many people view the video or join the session, but not working with the AI, right? So retrieval augmented generation or RAG is the agent a powerful tool for tracking complex questions. This is the agent take a question, break it down in a small part, and engage them with dynamic research process to get the relevant data and refine their understanding. Okay, so and deliver high quality while supporting an answer. Okay, with the process involve multiple iteration and a human in the loop feedback to ensure the final answer is accurate and comprehensive. The second is the code generation agents. Okay, the code generation agents represent another breakout in agentic AI. These agents can check natural language, require and generate code, leveraging existing template, libraries, document, and the best practice. They engage with a human developer for clarification, validation, ensuring that the code produced is both functionality and aligned with the project needed. This is a hybrid approach, increments our productivity and accelerate development cycling, right? So it's an intermediate scenario. Um, Multi-agents system break down complex tasks. Okay, in the last few months, it's more details around on the more manageable component, each handled by a specialized agent. For example, in a multitasking agent system for software development, a coordination agent manager the overall workflow, or while retrieval agents and coding agent focus on specific tasks. Okay, so this distributed approach allow each agent to focus on what is does best and while coordinate effort to efficiently solve the large problem. Um, Memory and inter-agent communication are crucial for keeping the system running smoothly. Okay, so it's different scenarios, more complex, but I think it's really very interesting, right? And finally, is the multi-domain agent system represented a significant leap in how AI can scale and handle diverse tasks. In this model, domain-specific agents are orchestrated by an agent running, which allows them to work across multiple domains, with representative themselves and a single agent to the user. The design is built to handle scalability, ensuring the ability, and to manage hundreds of agents. I think it's the key features here is that the shared context memory, which allow agent to transfer knowledge and coordinate with each other seamlessly, right? So this system is efficient, highly adaptable, ensure that tasks are handled without bottlenecks, and even in the scope and responsibility increments. I think in my mind, you're thinking about similar with the department, right? So you have the different department with the, for example, marketing, sales, and anything department. You have the different needed you knowledge base. So when developing an AI agents, right? So there are four critical considerations that must be addressed for success: knowledge, action, security, and evaluation, right? So the first, providing agent with the right context of knowledge, ensure they understand the environment they operate in, you know, in second, in equipping them with the right tools and capability enablement, so then to perform to necessary tasks. Okay, so security, for example, is paramount. An agent must have access only to resource they need and then be protected and again misuse it. Lastly is evaluation and ensure the tasks are complete correctly and allowed to perform optimization and address there is an area for or the foundation for effective or an AI agents, right? Um, in my vision, I really like it, and I'm going to in this session is to demonstrate with the capability around of Microsoft ecosystem. So Microsoft offer a variety of agentic framework for the different level of agent complexity. So the most popular, or in the research people maybe is AutoGen, but today semantic kernel is the ideal for choose seeking for to around of the build powerful single agent solution with the flexibility to expand to multi-agent system, right? Is only one framework specifically for production environment, enterprise capability around of the Azure or the rest of the cloud provider, but the most important is your development around the Java, .NET, or Python, right? So the second is Autogen, and a more robust multi-agent framework provides pre-built orchestration pattern for managing complex system and low code, no code environment for building agents. And the most interesting is the front end. You have them more visualized, and the people is now familiarized with the agent. You have a capability with the input data and outputs. But the problem is the Autogen is the version 0. It's no general availability, and it's no support for the production environment. It's only the environment for the research. Finally, is the task weaver is the focus on the ability to manage a complex data structure and provide a tool for customization, stateful planner. This framework cater to a range of needs, from building simple agents to managing large, complex systems that require coordination across many specialized agents. So semantic kernel, I think, is lightweight, open source, production ready, orchestration middleware. Okay, and that lets you AC to AI to your apps. So I recommendation all time semantic kernel. And the most important is the connectivity with the rest of the services, right? So you have the capability with the AI services and the local model with, for example, Olama, LLM Studio, Onyx, or Microsoft E, and you have created the different plugins and connectivity with the third-party tool, right? So let me check a demo. So you think about my recommendation is that all organization need then working together with the library around of the about of agents. So this is my library. It's the example library. Okay, so you have the different profiles with different industry. Okay, so for example, program manager, software engineer, project manager, or for example, in this case, is brand analyst, content editor. So the most important with your library with agents, so is you prompting. Okay, so this is a only one method, or only one deterministic with the price in an hour, and you calculate with the ROI. It's very simple. And the at your team, this is the meta prompting. This is very important prompting, right? So today I have a demo specifically for semantic kernel. So I have let me check, and I have my notebook. So specifically for you create with the project in .NET, Java, and a Python support. So you only reference with the nuggets. In this case, it's Magic Kernel, agent abstraction, agents core, agents OpenAI, because I have Open Azure OpenAI, and connectors of OpenAI, right? So using the Newton's of, yeah, and it say, yeah, an instant you only for using in your code. So the most important is the create the variable in every project with using semantic kernel or using Azure OpenAI. You have in the config zone. With the config zone, using the different variables, we're connecting with your API key, description, URL, model, etc. Okay. So you only for create of the instance for the kernel, right? So the kernel is very simple. You instance, so you kernel dot create builder dot Azure OpenAI chat complexion, and you have deployment name, API key, and endpoint reference, and build. Okay. So now this is the very big important part, right? Why you have this? This is the let's given the persona to agents, right? So you have an instance of the program manager, software engineer, project manager. You have only copied this prompting, okay? You have your library, and you copy the different capabilities. So we specifically description with you. Okay. So let me check. So this is a presentation, okay, around of the persona. So you need an instant the persona. You have a possibility, for example, create and capabilities, for example, in storage or in SQL or NoSQL database, or it's possible in the config. In this demos, is only for the text plan for only you. Very easy view. Okay, so the most important is this is in the every profile you have a possibility we create automation, but you need it instant the different profiles. Okay, you need them the safe word. In this case is approve. Okay, why do you need what do you need the safe word? Because in this case is proof of concept. Okay, so you need a stopping in the agents, because it's you're not stopping with the safe word. You have the infinity loop around with this action, right? The another capability, another option, you have a created the safe word, and additional, for example, the iteration. You have possibility introduction the number of the iteration with this loop, with the orchestration with multi-agents, right? In this case, is for example maximum 10. The most important is the final task. Okay, you have the instant the profile, you have to create the semantic kernel builder, and now it's only the description with the task. In this case, is I want to develop an app which will provide me calculator, keep it simple, and I get the final approval for manager. Okay, so let me go. I think 3 minutes. It's going. Go. Okay. So the most important is it's running. Okay, is thinking about, but it's really interesting because it's thinking about the project name, the creator, the all needing around the features and the functional requirement. For example, the first is basic arithmetic operation. The second is the user interface, other requirement, platform, localization, performance. It's really interesting, right? So deterministic with the no functional requirement, security and development standard, technology stack. Okay, so determine with the front end, the back end, and the testing. It's more important because more customer or more people is thinking about forbidden around of the testing. So have at the calculator the description for the timeline, right? So it's to say, okay, the project plan is 1 week, the UX is 2 weeks, calculator logic is 2 weeks, integration of a UE logic is 2 weeks, testing is 1 week, and the play to play store 1 week, right? And the costume is really interesting because it's say, hey, this is the cost approach with this and the deliverables, the open question, next step. It's more important because it's the agents is talking and the different thinking about to say, okay, the project manager is now working with the code. So it's prepared with the HTML, CSS, and JavaScript. So you have very funny because you have the generation with this. Okay, so let me check. What happened? This open. Yeah, open. Yeah, let me check. So you have the calculator. It's this. Okay. It's operational, right? So it's, for example, 5 plus fly, it's a 10, right? So it's it's very important because it's a creator of the whole. And the most important with this, the approach is the final conversation is the summary and the key outcome, action required, the different approach, and finally is the confirming with the software engineering and the program manager. He has the all reason with the project manager is approval. So at the finally is the project manager say yes, right? So it's thinking about this good example with a round of the agents around of the capability with this topic, right? So it's possible implementation with, for example, the different capabilities, or include, for example, the brand analyst, or include 4, 5, 6, 7. You have a possibility in the infinity loop with this, okay? So remember, because I think it's 1-2 minutes, okay? So remember is using the Azure AI Foundry platform, because it's a capability with the integration around the GitHub or the Copilot Studio, or have ability with the, for example, the agents with using GitHub Copilot. And the another part is using capabilities around the Azure capability on hybrid, because it's Semantic kernel, it's possible run locally. Finally, it's only one the reflection. Okay, so you have the how to start with agents around of this, right? So I think it's all people now it's discovering with the Microsoft 365, GitHub Copilot, it's a Meridian, right? What do you need more flexibility, or what do you need more complexity in your project? You have a more scalability, right? So is the first iteration is the Copilot Studio is around all the capabilities around with goes, you know, uh, power platform, business, thinking about the business people with the no technology stack, and Copilot Studio, I think, is the better. What do you need more flexibility and more complexity in your project? You need them, for example, more extend for your business logical. I think you introduction the Azure AI Foundry with your project, and you need them for extend with this magic kernel with the demonstrate the capability around of the big projects which you need around of the, you know, is extend the AI capabilities in your project. Okay, so it's fine. So thank you so much. I do not sure have questions maybe. Okay.
I get back on screen. There we go. No questions. We did have, as you know, a small technical issue with the original link, but thankfully we've looks like we've rescued it. We do have nearly 30 people online live. So, folks, if you can hear us, and if there's any questions from you, well, please by all means just throw your questions into
Perfect.
the chat. We'd be happy to take them.
Okay, perfect.
Anyone else? Nick, Damian, any questions from Manuel from a session or?
One for you, Manuel. Some examples of where you're actually using these in operations or in services at the moment, and which you're defaulting to the most.
Well, I think it's you know, Microsoft ecosystem have a good bring opportunity with the open gate with the different scenarios around of this, right? So it's with using Azure AI Foundry, and I think it's thinking about the people, it's more complex because you have a create at the Azure AI Foundry, you need to create the hub with the create the project, but you create the project, but you need to extend with the hub, right? So I think it's more easy because you have in the Azure AI Foundry, for example, you have the available the old services, and the next few months it's available for the old services. But I think it's good opportunity with the create of the agents, right? So it's more easy. It depends with your level. You have, for example, introduction with the Copilot Studio. You have intermediate level. You have possibility of AI Foundry or using Semantic kernel, right? So I think it's good opportunity, and the AI momentum, you know.
Are there scenarios where you're actively using it? So, for example, as a developer, I'm assuming GitHub lives a lot in your live streams and your life cycle.
Yeah.
Have you done custom agents into your CI pipelines using Azure AI or any of those tech stacks? So code reviews and stuff, going beyond what obviously GitHub Copilot does by default, but more custom. DocGen.
Yeah, I think the capabilities around extend the old capability with using the AI Foundry capabilities extend with the agents using GitHub directly. So you have the open the door with using your owner, your LLM specifically for example, naming convention or your architecture, right? So I think it's the open.
Fantastic. Thank you. An interesting presentation. Thank you, Manuel.
Thank you, Damian.
I have a question. Which is your best tool to develop agents? Is it AI Foundry or AI Copilot?
Well, it's a pickle. It's a pickle question. I think it's depend. Okay, so you have, for example, you are enterprise company and you extend the capability with your software, and I think maybe using semantic kernel because you have the logical business and extend the capability with the difficult component, right? AI Foundry, I think, is really very easy. Create your agents, right? So it's your introduction with quickly. So it's similar with extend capability with the Power Platform or Business App, right? You drag and drop box, and you have introduction to document. So it's the rack architecture is really very simple. But I think you need a very complex scenario. You need the rest of the services, right? So introduction with the Azure functions, or maybe you have the connection with the third-party tool, right?
Yeah.
I think it's depend. So it's a typical question.
Agent is like a collection of different tools.
Yeah.
To do different actions.
Yeah. But I definitely Azure is the stack and the technology with using and developer for the agents. I think yes, it's more maturity with the rest of the. My opinion.
Yeah. So, what's one of the best agents that you created for like a work, or it could be anything that you've done?
Microsoft 365.
What do you create it for?
Yeah, I think now I really like it better. GitHub Copilot, for example, and the all implementation around of the agents in background, and you supporting, for example, the extend the capability. Damian is common, right? So the result of the pull requests on the create or the capabilities around this, or the naming convention, you have a introduction with this. So I think it's the better solution with this. This, for example, for me, it's more travels. I think is the Amadeus agent in Microsoft 365. It's better.
Any question from you, Kevin?
No. Most of that went over my head. To be fair, I'm not going to pretend to know semantic kernel.
Any opinions on MCPs in this game?
I genuinely think, again, I'm just kicking the tires at the moment, but I do think the MCP stuff is something that's going to be a real game changer. So I've deployed the kind of the standard one into my GitHub Copilot, just trying to figure out some scenarios to kind of play around with it. But I think, like, to be fair, when we're talking to customers about AI solutions, the first question we'll ask is, can you do it in Microsoft 365 Copilot? Because if you can, there's no point in recreating right? But there are a lot of scenarios, and when you start digging into customer verticals, so if you start looking at the pharma industry, the finance industry, and the various different breakdowns of sectors, there's always going to be some unique scenarios that they need to bring their own data. They need custom kind of workflows from agents. That's what we're trying to figure out at the moment. So there's a lot of promise in the MCPs then.
Yeah, I agree. And one to hit if you're just playing with it in Copilot, plug in the Word one. It's really good at actually getting your docs built.
Okay, nice. Well, that's a good tip. That's
down
for tomorrow.
So the next session, folks, is Damian. He's going to speak about IoT in Azure.
Sure.
Yeah. So Manuel, thank you so much. You're welcome to hang around and learn a bit from the IoT master. But if there's any more questions when we'll come in for you, we'll get them to you directly if you're on the line now, or if you drop off, I've connected on your social. So
perfect. Thank you.
Cool. So Damian, over to you.
Right, guys. Well, I'd like to say thank you, first of all, for giving me the opportunity to join you here. We're opening a can of worms I don't think has been addressed on this forum till now. And as cans of worms goes, this one is big and deep and gets complicated really, really fast. So in order to kind of, I suppose, foundationalize ourselves, I like to maybe spend a little bit of time having a talk about what is IoT, and try to do this at a way that is accessible for everyone. And I think the answer to that is smart homes. Start there, because I think everybody's seen a Philips Hue bulb or has played with some sort of a smart remote control in some shape or form. And we'll try and build an analogy, if that's okay, as far across to the industry, and figure out how can a Philips Hue bulb have anything to do with a rubber injection machine. And if that works, then we should be able to take a peek at what's going on here.
Yeah, I think that's actually a really good way of pitching it, Damian, because as you said, everyone will have an Amazon Echo or a Google Home or Siri. Well, Siri's not, but you know what I mean. People are used to kind of throwing commands at things and connecting things around the house. But when you and I had a quick conversation on this earlier, it's when we look at, look, we're all Azure MVPs, right? So we've got Azure IoT hubs, and we've got all this IoT capability in Azure. And if I start thinking about how can I use that to, if I'm being selfish, to think about our own customers in Ergo where I work, how can I use the Azure IoT capabilities to build out new product offerings and new scenarios for those customers? I need to get the thinking hat on. And I think a foundational understanding of linking the knowledge that we might have for that connected home to then connected business to bespoke scenarios. And we're not going to cover it all in one session tonight.
Not a hope. No, not a hope. We need a day. This is a full-on workshop to go through this stuff. So we'll highlight, and we'll try and not get too stuck into the protocols and the technology stacks that exist. As you said, purpose here is making incredible technology incredibly simple. So in front of me and in the cameras, something that everybody will recognize in some shape or form, a Raspberry Pi, and it's sitting in an armored case, basically designed to make sure the thing doesn't get too hot. That assumes it's doing something. Everybody has seen a Pi at some shape or form over time. But the question really changes a piece. How many people have actually seen what is or was Azure Sphere, right? And what the hell is Azure Sphere when you look at it? Well, it's a Raspberry Pi that looks a bit different, right? They're just daft boards, and there's all sorts of them. That is the older developer board. Then we got a cooler one from Microsoft, and for the uneducated eyes, this one looks like one of those BBC Micro little microbit things, except it's probably 100 times more powerful than the microbit, and that became a Microsoft's IoT hub. And we get ourselves into a lot of trouble very quick, because when we start thinking about doing IoT in Azure, I kind of see these things and I'm thinking, right, I'm tuning out. I'm not an engineer for electronics. I'm not a microcoder. I'm not writing firmware. What's this got to do with Azure? And the reality is not a lot. And if we go a step further, the real question is, what is it that I need to be doing, and how can I bridge a smart home? Because I'm not building boards like that in a smart home. I'm buying devices and I'm plugging them in and I'm expecting them to work. And the same is very true when I move into the industrial world. We buy really expensive hardware, and that might be a conveyor belt. It might be some sort of a medical device keeping an eye on your blood pressure. It can be absolutely anything. And really the heart and soul of it is controlled by something as small as these boards. And in this particular case, I'm showing you what is commonly known for the enthusiasts as an ESP chip. Really easy to program, really easy to code. You can do it in YAML. So if you can write a bit of bicep, you can definitely code these things. But again, I don't need to. I don't want to. I want to understand, can I not just take something off the shelf and use it? So let me ask a question. Home Assistant. You guys have heard of Home Assistant? Okay, so what is it? Well, Home Assistant basically is this simple piece of software. It's free, and it will sniff. It listens to your network and he figures out who's sitting on it. And it says, I see the telly. I see the washing machine. I see the Alexa device. I see your table lamps and all of these different things. I see your Philips Hue bulbs. And Home Assistant's purpose in life is figuring out, okay, now that I see these things, they all talk a different language. Those being Chinese, French, Japanese, or in this particular case, we call them protocols. So each one of them have a different protocol to speak. And Home Assistant's task really is to learn how to talk that particular protocol and essentially allow us to see what that device can do. So there might be a little bit of an authentication engine at the front of it to say, is it okay for me to talk to you? So yes, what's your username and password? Okay, then we've got the secrets, come on in. And once you do that, then we do a little bit of a handshake and we'll say, okay, welcome aboard. I'm a bulb. I can turn on and I can turn off. I can have brightness and I can have color. Thank you very much. That's all Home Assistant needs. Now I can do something with that. And that starts the journey, essentially. I don't know if we're sharing screen at the moment, Kevin. Can we put a screen up as well? Just
yeah,
for a minute? Yeah, you don't need to be looking at me, but what I'll do is I'm going to actually just see if I can get the computer to share another screen. And I'll show you for a second a Home Assistant that's running on my own network. Now, there is a reason I'm going here. So let's expand on that in a minute. But here's the discovery that we talked about a minute ago. So this Home Assistant is sitting on my network, and it's seeing all sorts of different things, from the washing machine to the table lamp, the Alexa media players, and all of these different things. And if I go in and I take a look around at any one of these, I start to see more choices. So for example, here is something that we would see in an industry. It is a water pump. So this is driving the house. But more importantly, here I get to see information about it. I can see what the temperature of the system is, how many times the actual pump has started and stopped, what sort of pressure is on the water system. Now, think about that in an industry. That might be a pneumatic system. It might be responsible for actually getting stuff from one part of the environment to another. It could have all sorts of different things. But the key piece here is I get to see this information. And not only do I get to see this information, but I also get to graph it. I can see all of the stuff that's been happening, how the pressure has been sensing, what's been going on in the environment. And I can use that, maybe a little bit like what Manuel was showing a few minutes ago. I can do predictive analysis on that information with AI, and I can start making decisions. But I'm doing all this in Home Assistant. I'm doing this in my smart home. And when I walk away from the smart home and I walk into an industry, I want to basically do the same thing. So a typical thing we'll see in both environments, a solar panel. Lots and lots of smart homes are putting up solar panels at the moment. But so are lots of businesses. And typically, they put up a lot more of them. Now, the data we're going to collect from our solar panel is always going to be the same data. The same idea as if I'm sitting inside an office, the same data I'm going to collect there. A temperature, a humidity, is the door open, is the window open, and all of these different things. So as I start taking a look around, I sort the building and I can start seeing different things. What's happening in these different rooms in the buildings. So I'm classifying all of that data I saw in a couple of minutes ago, and I can make some decisions about what is or isn't happening. And that's really what IoT is about at the end of the day, because IoT effectively is turning around and saying, I have a device. I want to know what that device is. And no, I don't want the app from Hue. I don't want the app from LG. I don't want the app from all these different apps. I just want them in one app. And this is really where Home Assistant wins. There's lots of different ways of doing it, but by far the rock star on this is Home Assistant. Why is he the rock star? Because everything is open source. We basically get to see the code. How did I talk to that particular device? And that can be a robotic lawnmower, a vacuum cleaner, a bulb. And that code is free and open. So we essentially can use that to our advantage. Now, one of the things Home Assistant does is he basically tries to take all of these languages and translate them into something that's common. And that common thing is what we call an event stream. So in this case, when something happens, send me a message. So when the light bulb comes on, send me a message. Well, what message do you want me to send, Damian? Well, it'd be nice for you to tell me the name of the light that turned on. Did you turn it on at full brightness? And maybe did you change the color on it? If the bulb can change color. So that's my message. So we define this message and saying, when a bulb happens, these are the things I want to know about it. And don't bother sending a message in the meantime, because I only want to know when it's on or when something happens. So send me an event when an event happens. Now, sometimes the bulb might be a bit faulty and he might not say I'm alive too often. So every now and again, I might want to go back to Mr. Bulb, are you still working? Yes. Are you still on? Yes. So in those particular cases, we can do a polling. We can ask, are you okay? And put that back into the event stream too. But we typically don't want to do that because that means I'm asking more questions. Now, that stream is known as an event stream. And if you think about Azure, we have event things as well. We've got event grids, event hubs, and all of these different things. And what do they do? Well, they tell us when Azure is doing something. If I go into Azure and I take a look around Azure to figure out what's happening in this thing, I can come in here and I can start looking at the activity logs and I can sync those into the grid. And guess what? They're exactly the same thing. When somebody deletes something, when somebody deploys something, when an event happens, I record it. And what data do I record? Well, the who, the what. It's exactly the same thing, right? So it's just a slightly different message. So I don't care if it's a robot, if it's a car, if it's a rubber injection system, if it's a heart monitor, they're all the same. I just need to classify the type of message I'm getting and the data that's important for me. Now, with that piece of information, we can make this a little bit simpler. There's a term or 4 letters that you'll often see chained together, MQTT, message queuing transport something. I forgot what the last one is, but it's not important. What matters here is that this is the standard that we use for sending messages. And this is one of the first changes that has happened essentially in Microsoft's IoT journey. When we started this, Microsoft looked at MQTT initially in the original version of IoT Hub and says, yeah, that's not for the professional lads. We're going to use a different one. We're going to use a thing called AMQP. So basically an advanced messaging queuing technology. Well, it turns out that when we switched over to the new IoT operations platform, which is what Microsoft shipped now, and we look at what's happening in the event grid, guess which protocol they decided was actually the proper one to have chosen? The one they showed the first time. So MQTT is the way we move forward. And that's brilliant because that means everything I've learned in my beautiful hacking of around the house, MQTT sitting in the middle of this, happens to be exactly the same messages that I can now send to go up to Azure. So that actually means that I can come in here and all of this information, this can be sent off an MQTT message and Azure can take that directly into the event grid. And that means immediately anything that shows up on the event grid in Azure, we can then talk to the data guys and says, hey, data guy, can you go to that Azure Fabric thing, listen to the event grid and grab me all the data? Well, I can, Damian, no problem. Well, can we make a Power BI dashboard for that? Well, I can, Damian, no problem. Well, that's brilliant. I love it. So now all of a sudden, I have a very simple IoT solution. I can have Home Assistant doing all the talking to these devices, and I can do a nice MQTT connection up as far as the event grid and then put them into the things that says in Azure. Yeah, but there's only one problem, Damian. Who's going to support this? Because that's an open source product and it's supposed to be used for homes. And we're an enterprise and we've got lots of buildings and this is not going to scale. And you kind of, that's a fair point. It probably isn't going to fit. So what do? Well, we need to replace Home Assistant in some shape or form, don't we? That is essentially what Azure IoT Operations has done effectively. So I'm going to put a slide up for a second just to kind of help us picture. And I'm cherry picking these slides as you might imagine, rather than actually walking through a full deck. But if this one, I think, is as good as any to put up here. So what I want to show in this slide, and see if I can get the little laser pointer to do its thing. He will. Okay, so here we can see at the side, we've got these devices. Now, this time I've said industrial assets. So a nice big robotic arm or some sort of a production press, or maybe it's a machine making tato or wrapping presents in them. It could be anything. These are still the same idea as my little robot in the house or my bulb. They're all devices. Small ones, big ones, solar panels, it doesn't matter. They all communicate with their own language. So in this particular case, we're looking at things called SCADA, SCP. Again, for those that live in this world, these mean things. For those of us that don't live in this world, they mean nothing. But what we need is some way of getting that message communicated over to the Azure IoT Operations, the Home Assistant effectively. So in Home Assistant, as I said to you, we had the open source protocols where we could actually see, well, how do I talk to this thing? So a common one that's not on the list will be something called Modbus. Or if you guys love cars, you've come across a CAN bus, right? It's where you plug the little dongle in and you can tweak your car. So all of these buses are known. They're defined standards of how you communicate with things. So in these particular cases, IoT operations is responsible for making some type of a communication to these devices. And of course, being an open platform, we can extend it. We can make it talk to these different ones. So instead of putting in Home Assistant, I put in IoT operations. Then I might want to do some more pieces on my edge. What would I want to do on my edge? Well, I might make a decision, say, you know what, if there's no motion in the room, then 5 o'clock in the evening, turn off the lights. Now, rather than that stuff all going up to the cloud, I can do that here on the edge. I can put a bit of logic down here saying, look, is there any motion? No, nothing in the last 10 minutes. Is it after 5 in the evening? Yes, it is. Well, then do me a favor and send a message back saying, tell the robot to go to sleep. Nobody's here to see him do nothing. So in other cases, we may make a decision saying, I need more context. So in that case, I may actually send it across the cloud. And this is the difference here. Our edge device, which essentially is the industrial version of the Raspberry Pi that we started off with, except it's not a Raspberry Pi. In IoT operations, it can't be a Raspberry Pi. It has to be a small PC or bigger than that, right? So sorry, bye-bye. That one gets put to the side, and instead we run on something like a small Intel NUC or other what they call industrial PCs, which are about the same size as a Raspberry Pi, but they happen to run an Intel chip, and they might sit in the actual power DIN rails or stuff like that. So when you've got your circuit breakers at home, that's where the PC is probably sitting in the middle of those things. Or it's in a server rack. It really depends on what you want to do. Now, once we do that, we build our bridge. We build that bridge into the cloud, and we've already guessed this. This is the event grid, or this is the IoT hub, or this is the IoT operations that are sitting in Azure. And once that stream is in Azure, where can I send it to? Well, it goes off to all those things you want it to go to, of course. So it essentially lands into the cloud, Fabric, Copilot, Power BI, Azure Functions, whatever, they get to process it. But here's the thing. Look at the direction on the arrow. It's bidirectional. I can actually make logic. So that stuff that Manuel was talking about a little bit earlier on, saying, hey, Damian, well, it's not as simple as 10 minutes gone, no motion in the room. We should also take into account, has the alarm system been turned off, and taken into account all of the other rooms in the closer facilities. Maybe there's a meeting going on. So then I can take all that data and hand it over to Copilot and say, look, here's the situation in the building at the moment, or for the last 20 minutes. Now, based on the information I'm sharing you, what's the probability that there's need for the lights to be on or the heating to be on or whatever the case? Well, the probability is they should be all turned off. Great. Send the message back and turn them off, right? So we can start building models. We can do all of these different things up here. And what makes Microsoft really cool is those models are machine learning models, and they can run here. So after we spend a little bit of time learning and training them, they can actually run on the edge. Another reason why we're not putting a Pi in here, because we actually want to drop them in. So how do I do that? Well, there's the answer right there. Everything that runs on this little computer is a container. And how do we manage containers? Well, Kubernetes, of course. And how do we manage Kubernetes from Azure? Through the Arc system. So when I sit back and I look at what's going on here, I can see everything is built on top of Azure. We have Arc using to make secure connections between the on-premise environment and the cloud. So I told you I can take MQTT and send it up to Azure. I need to put security on it. So Arc takes care of all of that. I know that I want to run my Home Assistant, my logic. Okay, then that's a container, and I'll use Arc for Kubernetes to tell them what containers to do. I want to take an AI model. Sure, no problem. Put it into a container. We can have Arc for Kubernetes take care of it. So all of this stuff is actually stuff that we're very used to doing, just in a different way. So if you're spending your time communicating with these devices, all he's really doing is he's learning how to talk the language these things talk and bring them back in a way that we can actually respond to and take effect on. Now, before I go any further, any questions for clarification?
No, none in on the chat, and you've actually explained it really well there. So I think the slide was good for context. I think the Home Assistant demo mapping then over to Azure IoT operations is, at least for me anyway, that's given me a much better idea in my head now as to what we're talking about.
Okay, so really the thing is that I have to replace Home Assistant, but I don't. And I would almost say anybody that's new to this, don't replace Home Assistant. use it to start and figure out how to actually get your home lab, because we all start in a playground somewhere. The best playground you can start with is Home Assistant in your home, and get that bridge to essentially send MQTT. Now, something that's going out from Home Assistant in this case is known as an MQTT stream. So there are features inside Home Assistant say, hey, I'd like to stream everything that's happening out across MQTT. So turn that one on. It takes one line, it says MQTT stream, done. Right? It's that hard. Now, once you do that, we then need to figure out, how do I connect that stream up to Azure? The answer is, don't bother, right? We can run a little piece of software on your computer, Windows, Macs, Linux, MQTT-X, and that software will basically give me a nice visualization of what messages are coming across the stream. Let's use that to figure out, what does a message look like that comes from a light bulb, or what does a message look like that comes from a washing machine or a vacuum cleaner or a solar panel or whatever the device is. And we get a little bit acquainted. Now, these things are JSON. So again, you've all written ARM code or Bicep or Terraform. So this is not rocket science. We all know how to read a bit of JSON code at the end of the day, ugly as it might be. But that means we can actually start understanding the stuff that's coming across this event stream. And we get to kind of say, oh, I see. It's very close to real time. And I can see the context of saying he brought the light up from 20% to 30%. Or I done the opposite. I sent the JSON back to the MQTT, said, change that 20 back to 10. Crap, the light bulb dimmed. That's awesome. Now I got this command and control thing. I can see what's happening. So now that I figured out this stuff, this is when the next question comes in. Well, then let's get this up to Azure, Damian. I'd like to actually get that into Azure. And that's when we get the things a little bit more complicated, because now I have to make MQTT talk to Event Grid. There's lots of demonstrations how to do it, and we can certainly sit down and go through that. But the hardest piece of that is passing across the username and password strings that we need to do. Azure Arc, of course, hides all of that, makes it simple. You don't have to worry about it. So in our case with Home Assistant, we got a yak shave. But if we go to IoT operations, we got a secure system built in the box. So of course, from the industry perspective, that's the one I need, Damian. But from learning how this stuff works, yak shaving is definitely the way to go. So maybe it's time we talk.
I've got a question.
Go on, please, Nick.
How would you secure this? Is it just password and credentials, or is it used 2FA or something? Or
No, it doesn't use 2FA. It is password and credentials, but it's a managed service essentially. So if I'm doing it the Home Assistant connection, then it's a password and a secret, right? It's essentially the same as any other app registration, right? That's what it is. When I move over to things like Arc enablement, I'm not doing the actual managed. It's a managed identity on my behalf. So that information is going across the secure channel. Of course, there is a question of, whoa, you're sending all this data across the internet, Damian. This is great. I'll be able to sniff and I can see what their lights are. And more importantly, Damian, I can flash the lights red in the middle of the night and wake you up, or if there are sirens, cause you all sorts of grief. Like HTTP, this stuff runs across a SSL layer. So there's TLS and SSL sitting in the middle of things. So the channel and the communications are all absolutely encrypted. So we're not really worried about the man in the middle happening in this case. I'm not going to get into that it can happen scenario, because it can happen on everything. But we're building this on the concepts that we're trusting our two endpoints and we're doing our pieces. And Arc certainly is designed to secure that environment. And in the recent months, as in the last couple of months, that's become really, really good at doing this stuff. They've tightened up all of this to be fully managed with rotation and all of the other things that's needed to string them out. So maybe what we should do now is explode the edge, what we call the edge device. And why we call it the edge is because this is essentially what runs in your business, in your house, in your building. So if you work in manufacturing, you may have one building. Or if you work as part of a big enterprise, then you may have multiple buildings. And those buildings might be all in the same campus. So if you think about like a university for the world, there may be a decision. They're saying, you know what, we got 25 buildings in the campus. How many edges do I need, Damian? Well, one is probably all you need. But have you got separate controllers for all of the different buildings? How's the aircon? How's the access control? How's all of those things? Well, yeah, they're in each building because we built the buildings over 20 years. Fine. Then maybe the better option is to put the edge device into the building too. So we start to scale and take a look at the fact that actually I'm going to put an edge into each of the buildings. And those edges are built on devices that can be, as I said, a small NUC machine, but they can also be far more resilient with failover operating systems and all sorts of madness as we get into lines of criticality. But we start with a proof of concept. So cheap and cheerful. We don't need to get too complicated. We just need to prove the concepts first. So the real call here is, my edge happens to be a ship, Damian, and that ship is on its way across the ocean. Well, this is why Azure IoT is kind of cool, because this is a PC. And I'm streaming all the information that's happening within the ship. So the engines or whatever is happening in the ship, they're being picked up by the IoT operations. But I can't get to Azure because I've got no 5G connection, or I've got no internet connection, or Starlink is not working for me at the moment. What happens now? Beautiful stuff. MQTT has a store and forward feature. So essentially you can set them up to say, that's fine, you're in a disconnected state. Keep storing, keep storing, keep storing. When you get your internet back, start forwarding and bring me back up to speed. But remember a few minutes ago, I suggested on an earlier slide that we could actually take things like Copilot, so AI models, and we could possibly package them up and we could possibly run them as a container. Now think about that for a second. If we were to do that, and I am sitting on a ship, then I can have the IoT operations get its data and maybe some of that logic. Maybe it's a camera and I'm watching the captain's quarters and I'm saying, there's a person approaching the captain's quarters. Well, then the camera can put a detection on us and say, yes, there is. I should send an alert. And that can happen here on the edge. So the data does not need to go to Azure to be processed, to be sent back, because that model is a known model, right? So now I can start much simpler logics as well. But that's a good complicated one, because AI typically is used with ML models for doing vision detection and stuff. So we can build those and bring them down. So again, how complicated do you want to get? Doesn't matter, because this scenario scales. Now remember, there's never just one ship. We've got cruise liners, lots of them, or we've got auto liners, or whatever the different things are. In those particular scenarios, this is the next thing that Azure has to offer. I want to do an update, and I want to actually take that new model. Well, it's a container that we built in Azure. And then I turn around to Azure Arc and I say, push the new version of the container down. I have massive scale. Try to do that in Home Assistant. Yeah, start in the first one, move on to the next one. I'm not doing a third one. It's too much, right? This thing can scale to thousands, where my simple hacking that I'm doing on my home, the technology is essentially the same concepts, but it doesn't have all the locks and the bolts and the bells and the whistles that are needed to wrap it up. And that's really what the IoT tools are about. They're about basically figuring out how to build this thing with resilience, repeatability. What did we call it? Infrastructure as code? Guess there's some analogies to be built here now. Kubernetes using manifest files? I guess that's what's running under the hood, Damian. And protocols and communications? Exactly the same as what we have. So it's not rocket science. It's incredibly simple technology. Now, if we do that, then the next set of questions is, well, talk to me about what's inside IoT operations. I'm kind of curious. And the answer is some really, really awesome things that I've never heard of before. So the first one is Archi. Hands up for those of you who've seen what Archi is. Yeah, exactly. Probably none. And if you have, I'm impressed. Please ping us on one of the socials and tell us where and why you've seen it. It's an open source project, and its job is to do one thing: snoop and listen. Remember, Home Assistant was able to snoop and listen to all the stuff on my network and said, I found the telly, I found your robot, I found your light bulb. Well, guess what Acri does? It does the same thing. Now, here's a one. I have a quiz for you guys. On social, I want somebody to actually figure out what the letters A, K, or I stand for, and ping up Nick or Kevin and tell them what those letters stand for. And I can see them trying to do their perplexity at the moment to get the answer to that. But the name actually has double meaning. It's a Greek word, and it also is an abbreviation for something to do with the cloud. Leave it at that. In the meantime, for the rest of you that are paying attention and are not Googling, we have an OPC-UA. Another thing I've never heard of before, Damian. This happens to be the business answer for managing my manufacturing plants. And that piece of software cost me, well, let's put it this way, a couple of zeros at the end of the price tag because, well, it's a business solution. What is it really, Damian? Well, it's kind of MQTT put into a different piece of clothing and doing something quite similar at the end of the day, defining what the messages are that you should be sending me and I expect to get from you and how they're formatted. I love it. Somebody got it bang on. A Kubernetes resource. And the Greek word for edge. So essentially, its job is to listen on the edge, figure out what devices exist, and it also allows us to get a Kubernetes interface into the edge. So Acri is something that's really, really cool. We'll sideline that and we'll put it over to the side. And we'll spend a day looking at Acri. But we won't bother doing that till we figure out how a lot of the other things work, because that's just, I'm getting to show off at this point. So we won't do that. We'll focus on get the first things working. OPC UA is essentially the standard that a lot of the industrial systems communicate. So when you turn around and say, hey, my Philips Hue speaks the Hue language and my thermostat speaks Z-Wave and my Hue bulbs talk Zigbee and all of these different things, OPC is basically the language most industrial machines speak. And to talk to them, and then I have to have a broker, a server, and I have to pay for that big time. Basically, what they're saying here and what Azure's original IoT help said is, this is the language we talk to. So if you're in industry, you speak this, or you don't speak. It's the only language you talk to. So again, that's great, but the reality is not everybody speaks this thing. So the next one beside us, MQ. Guess what this is? It's MQTT. This is the baby. This is the one that we all want to talk to. And this did not exist inside the original versions of the Azure IoT solutions, but it is absolutely sitting right in the middle of the heart of IoT operations. This is my MQTT. This is what we learn and work with first. Then we can extend it to OPC UA. Then we can go up to Acri. So if you ask me what direction am I learning, I'm starting here. This is the start point. We figure this thing out. When we figure this out, this becomes an awful lot simpler to learn. If you start the other way around, go here next. So you may have a background in industry, and if you do, then this is probably your start point, because you'll be looking at that's what the kids are using. Us professionals use it this way around. And that's kind of the real theory on this. This will be definitely coming from that industrial, expensive professional services. This one would have all been looked at as, yeah, that's what the kids that are messing are doing. But the reality is, this one kind of drives most of the damn planet. Now, over here, we have data processors. I don't need to describe what a data processor is. It's taking a look at the thing and it's doing a massage on it, saying the data that come in here for about thermostats is in Fahrenheit. But gosh, we're in Europe. They need to be all integrated. Or this particular thing has got left-hand drive and the rest of Europe is right-hand drive. Okay. So this is where we make those contextual changes to the data depending on that model that come in. I told you, figure out what the message looks like, and then I can massage it. So when it leaves here, the bulb that come from Hue talks this way. It calls it, let's say, a RGB model for the colors. But the bulb that I bought from Govee, it didn't talk. It had flipping a different model. It wasn't using RGB. It was using HS, whatever it is. I can't remember anymore. So here again, we can take these and say, unify them so that when I send them up for processing, they're all in RGB format. So I don't care what type of bulb is sent to me. So this data processor allows me to do that. And it does it on the edge. So it prepares it beforehand, but I make the model up in Azure. Layered network management. This is the security channels. This is what we talk about and how the plumbing works. So the network guy figured this stuff out. And then the operations experience. So ultimately how the things pull together. So we really focus on this layer here. We start with these two, preferably if you have no experience, MQ. If you're coming from the industry, OPC. We'll probably cross across the data processing once you get more than one device in or multiple devices of the same type from different manufacturers in to start making things look tidy. And then we go into automatic discovery. How many solar inverters have I? How many air conditioning units have I? Find them. Did somebody plug something into my network? Find them and make them available to me. So that's essentially what happens there. Now, with that done, we can finally take a look at what the picture looks like. Are you ready for this? Nice and simple, isn't it? So this is IoT operations zoomed in. Now, this is when we start taking a look at, well, why I want to know what Kubernetes does, Damian. Well, now I'm going to answer that question for you. Kubernetes runs a couple of different agents. I just happen to have explained them. Archie, I have the MQ server, I have the OPC UA, and then I have the data processors. So you can start to see here how all of these different things communicate. So Archie is not important. He sits to the side and he helps. IoT MQ, he's the guy that gets the messages. OPC UA is the guy that says, I get the message in from the industrial machines. And what does he do? He turns them down into the thing that the kids use. Everybody uses the common language. Do I need to process the data to make it all look the same before I send it somewhere? And where do I send it? Northbound. We're going north to Alaska. We are going north to Azure. So we leave and we head on our way to the cloud, right? So effectively, it ain't that complicated. It all sits on top of Arc, which sits on top, mine's Kubernetes, and I got a couple of containers. And those are the ones that are sitting in box. And after that, I can add my own. So my ML models, or maybe I have a device that doesn't talk MQ, doesn't talk OPC UA, but instead talks something that Home Assistant talks. Well, in that case, maybe I'm using a Schneider C-Bus system, or maybe I'm using a KNS slicing system. How do I talk to that? Well, I know a good open source project that might actually have the code to make that happen. It's called Home Assistant. Go over there, take a look at it, see if they do a translation to MQ, and use that. Where'll I put it, Damian? Into a container. Where'll I run the container? Seriously, you run it on your edge. It's that simple. And then you kind of, I don't write code. Well, then I can give you another hint. There are products, packages, and solutions. One good one is called Node-RED. Anybody hear of that one? Right? So Node-RED is another one. So we have another day of stuff to go through, and it's nice draggy drop. So it looks just like the Power Apps. So if we've got Power Apps guys that like stuff and they want to do IoT, we'll start you guys with Node-RED. So there's a whole lot of more fun we can have there. So that one is really good because it allows me to plug my car with the CAN bus, or allows me to plug in my industrial pumps with the Modbus into something like Node-RED and push out the far side MQ. So all of a sudden I can be monitoring my car up in Azure IoT operations and figuring out where the kids are going with it and how fast they're driving. So there's lots and lots of nice things we can do here as far as labs and examples come. But now that we have a good idea, we should be able to simplify this technology of what is Azure IoT operations. It is simply figuring out how to talk to devices, big ones, not so, where's the camera, Damian? There. No, there. Not so big ones. I can get these things all talking in a way that we can get them up into Azure. And when they're in Azure, well, I've my job done. You now make a decision who moves next. The data scientist, the Power BI guy, the analysts, maybe it's going into a SCADA system, maybe it's going into a building visualization solution. That's fine. It's in Azure. We're in Azure. Well, it's in a data lake. It's in a blob. It's in an event queue. It's in, well, Azure Fabric. It doesn't matter. It can be wherever you want it to be in Azure, and you can pick it up from there. And what about security? It's in Azure. If it's got its way into Azure, we can take care of that data using the native security features of that data feature that you're running on top of. So, in the interest of time, I think we have a good foundation here. At least I hope I do. So I'll stop and see if there are questions.
No questions, but actually really well explained. I didn't know most of it, but the diagrams with your walkthrough makes a lot of sense. And I've heard you talk. You and I would have plenty of these conversations, especially when I was getting familiar with the home automation stuff a good few years ago. And I'd heard you talk about MQTT and stuff like that, and wasn't really sure where it would fit in or what it was, but that makes a lot of sense, that walkthrough.
So I think this is something that's really interesting. And it's an area that can cover lots of different technology stacks. We could DevOps, we can bring in infrastructure as code, we can bring in IoT guys, we can bring developers, we can bring in Power BIs, we can bring in AI. This is where you bring your skills together because industrial technology stacks for the OT world, there's so much we can do. And just to kind of wrap it up, the picture I'm showing now is effectively a picture of how a flow would work in something like Home Assistant. And if you have a look at what's going on here, we've just talked through this. a light bulb comes on, and we get a message basically back to our state machine that we put into an event bus, and we make some decisions. So it doesn't matter if it's my home or if it's a multi-million, multinational enterprise or a hospital or a shop or wherever the case is. All of these technology stacks essentially run the same. And once I understand how those stacks work, I can crack open the IoT operations platform. Now, there are areas which are complicated. Don't get me wrong. Like, you do not need to know how all the plumbing works. Do I need to know how Kubernetes works? I don't. But does it hurt if I do understand how Kubernetes works? No, it absolutely doesn't hurt. It makes it easier to troubleshoot. So it's the same for all of these things as we look at these different stacks across us. I can and focus in on specifically the area I care about, or I can drill in deeper. So do I care about how Power BI works? No. But do I know how to use it? I can build a report, get the data up, and prove the concept. And then I can hand it over to somebody else and says, here's how it connects as a data source that I got from this robotic arm over here. Once you're doing enough of that, then leave it over to the Power BI guys to make this thing look gorgeous, because that's certainly not something I'm going to be capable of doing. And that's true for this whole story. So if IoT operations is something that you want to follow, start with the simple stuff that you can do. And that happens to be Home Assistant and MQTT Explorer, MQTT X. These are all free, and it makes things really simple. And then once you've kind of got that basics working, which I'm quite sure more than 50% of your audience has, then we can take a start at figuring out, well, how do I build up an IoT operation system, and what do I need to do to put that into play? And ultimately, that shows up as well inside Azure with stuff that you guys already know. It's just like Azure Arc, because, well, guess what? It is Azure Arc. It's an Ubuntu system that gets Arc enabled with a Kubernetes, in this particular case, K3S, which gets Arc enabled. And then once you've done that, we basically register the IoT operations, which is what? Containers that runs on the Kubernetes that's on the Arc, right? So the layer of cake is pretty easy. And then when I've got that working, then I turn on the IoT operations in Azure, which says, oh yeah, I want to talk to the containers we just deployed there, Damian. Okay. So it's not that complicated. As I said, incredible technology. We're just making it incredibly simple.
So I've got another question. Do you get much like projects with IoT in Edge?
I will tell you the truth. For a while, the answer was no. But of recent times, the answer is yes. We are getting a lot of proofs of concept. And I think that's the easiest way to do it. So what we've started doing now in Innofactor is packaging these things up into a very clean scoping of work, where we'll basically go out, we'll get an edge device in place, and again, go grab a NUC effectively and install Ubuntu on it. We'll Arc connect that thing up, we'll get it out, and then we'll pick one device in your environment. So figure out the thing that's the most important to you. Turns out, in many cases, it's the solar panels. We get the solar panel data over from the solar panel to Azure and get a simple Power BI up. And that's enough then to see people see real-time information. And once we start getting real-time information, then we start the second flow, which is back. Send the stuff from Azure back so we can turn around and say, I'd like you to actually change the inverter, change the air cons, or wherever the cases may be, and work from there. So now we are starting to see more of this. And honestly, timing is good because the technology stack is finally at a point where I actually would be quite comfortable in running this thing at scale. Beforehand, no, we needed this. IoT operations hub, and Kevin will know my feelings. I've been quite verbal sometimes, but this IoT operation stuff, this excites me. This is cool.
That's good enough a recommendation as I need to then start looking into it myself. If the master of IoT says that IoT operations is something to look at, I think it's good advice.
Oh, that's cool. This really is.
You deploy like little resources, so it's probably compared to price, it's probably quite relatively cheap.
It's not bad. It's like all good things. When you're not using them, don't forget to turn them off because. But yeah, we are in this case we're using Arc, right? So we're not paying a whole lot of money for Arc. And in the case of data, we can do it simply in a storage blob. So for 90% of what we need to do, we can connect storage Bob to Power BI and I'm off to go. And it's only when I start needing more advanced stream stuff, then I turn on more advanced stuff in Azure. And that's almost outside my scope at that point, because I'm more worried about helping the industry guys get their data up into Azure. There are teams of people sitting there. If I had that data, I could do A, B, and C. So all I really need to do is show them here the data is and how you can start talking to it. So help them see the structure of it. And then they're kind of, that's all I need, Damian. Good. Thank you. And then, of course, they'll come back in a few weeks and says, is there a reason I'm not getting this particular piece of information? Kind of, there is, because I didn't bother sending it to you. Do you need it? I do. Grand. Update the container, push it back down to the edge. Flow should happen in the next hour. Tell me you got your data. Good. Scheme has changed there, but you broke my report. That's not my fault. That's your fault. But yeah, it is pretty much that life cycle. It becomes quite fun once you get going. And the risks of breaking things only happen when we turn on the control mechanism. I'm controlling the lights in your office from the cloud. So we don't do that to start. We demonstrate it in a small piece just to show it's possible. But we typically say, gather in the data, get the information, start making some recommendations. So a little bit like audit mode in Azure. We audit in what's happening and said, if I had the power to make the decision, I would turn off the lights. And kind of, right, well, you know what? I agree with you. And you've been right for the last week, so I will give you the control to actually turn off the lights. And we work that way.
So, if you put it in Azure in Edge and that region went down, would you still have it locally?
Store and forward, and that's a feature of MQT or MQ. So in this building, we're using what Microsoft are calling. And let me put it back up on the screen. Click that button and go over there. No, not that button. That button. That one. IoT MQ. Microsoft are using what was known as a Mosquito MQTT server. It's a very well known and respected MQTT system. Microsoft have essentially forked it and extended on it, rebranded it to IoT MQ. And basically what they've done is they've just added more features into it and the secure connection needed to talk to Azure. But the answer is yes, we have store and forward. If you decide that this message needs to be stored and forwarded, you can then turn around and say, I want to retain the last 20 messages, or once it's forwarded, delete the damn thing because I don't need it locally. So that comes down to a feature of the MQTT bus. And that's known as a QoS setting inside there. So again, I start to get nerdy here. But the answer to your question, Nicholas, is yes, it's still there should you need it. And if you've lost connection because I'm on a ship on the way to the North Pole and there's no coverage in satellites, it can stay there too. And how long is it going to stay? Well, again, you make a decision. How much disk space have you at it? How long is it good before it's actually worth keeping? If it's there for a week, do you want it? Yes, I do. Okay, then we'll store it for a week. So yeah, there's typically no problem on that. Any other questions coming in from the big?
No, and we've got over 40 live viewers as well. So you
all sleep, guys. I really apologize. My God.
Yeah.
Or else they're all gone away hacking with Home Assistant and not paying attention anymore.
Well, maybe you've explained it so well. Maybe that there's no need.
Manuel, have you got any questions for Naaman? Home automation wise?
No. It's really very interesting because I think it's Microsoft going to the Kubernetes services around of the management around the IoT services, right? So, and I think it's the correct direction.
Excellent. Okay, well, I don't think we've no more questions coming in. So I think we're just on time as well, just up to 8:30 GMT for anyone in.
Can it not be dangerous to have like everything under IoT, your house and stuff?
Nicholas, yes, of course, there's danger. The reality is if somebody gets into your house and starts hacking, they can do all sorts of things you don't want them to do. So for example, this is why we have firewalls in the industry. You don't put your websites out on the internet without going behind a firewall and protecting them. Of course, we've got many customers that do exactly that when they put stuff up in Azure and then say, well, I'm getting these alerts from Defender. Why do you think it's going in there? Did you have a public IP address on your VM? I do. Well, that's not so smart, lads. So people make mistakes. So it's like everything. You kind of need to understand how the stack you're working on is architected. So the same is true even for my smart home here, that yes, every single thing in the house is connected back to one machine. And if you get your way in here, then yeah, you can ruin my night without a question. Cause me all sorts of grief and pain. But it's my responsibility to make sure you can't do that. So in these particular cases, for example, my smart home is never exposed to the internet. We'll use, I give a plug for a company called Tailscale. They make a brilliant mesh system. So that allows me to run a mesh from my phone or my laptops directly into the house. So I don't need to expose things to the internet. But if I did, I'd probably want to make sure the firewalls were secure, and I was using reverse proxies and do all the other things that are needed, and keep them patched and updated. The same is true in your industry. And the same is true for these IoT things. These will not be put into the normal network where you're sitting with your laptop. They will be in a separate VLAN or V network or air-gapped or wherever the cases may be. But that's all into the architecture design.
Nice.
That's what makes this thing so much fun.
Yeah, it makes sense because in fairness, that is a good point actually, right? Like because often I've been co-hosting this this user group with Nick now for a few years, and oftentimes there's presentations where I have no idea the context. I'm a traditional IT pro, kind of got into the DevOps and when I started working with Azure, and there's a lot of stuff that would be just outside of my wheelhouse or outside of my sweet spot. When I put my consultant hat on, my consultant hat says, how can I architect this? And if I architect this in a way that I don't have to know all of the under the hood data and code, I don't have to know that. I just have to know, for example, something like this diagram here, and how am I going to fit that into a landing zone, and how am I going to secure that for my customers? There's a lot of stuff, and I guess some folks at least who are watching this online now live, or who will watch the recording back, you don't have to understand this. You might not even have to ever deploy this for your own workloads, but there are going to be scenarios when you have organizations who will need this in, and you need to understand, at least at a high level, which way this architecture works. And as Damian said, what way you have to air gap or lock down the environment so it can just be as secure as possible. So there are two ways to look at it as well.
Absolutely. And then this is, as I said, this is when teams come together. You're going to find some geniuses that know all of these things, from DevOps right through to the network on the far side. But really, this is about pulling together as a team, a set of consultants or a set of engineers within your organization, and taking your skills, because unlike everything else, this one really does need the team to understand, or an architect that knows these technologies to kind of help guide that team, because all of these questions are absolutely relevant in the big picture to keep your operation at scale. Like, think, for example, I said ships. What if this was an airplane? And what if the control mechanism says, dip the rudder? It'll be like my poor plane back here beside me. There'll be two wings in two different pieces sitting on the ground. Not good. So the architecture really does matter depending on what's sitting on the far side of it. Is it so bad that somebody can get in here and flash my lights in the middle of the night? Yeah, it sucks, because it probably will upset the house and the wife and everything else, but no one's going to die over it. That may not be true in industry. So we have to be very careful. If there's light guards on machines and they get turned off, we could have fingers lost or worse. So it is super important that as we think a little bit about this, and this is also really why I say we gather the data from the site and bring them to the cloud. The control mechanism going backwards, we proved that you can do it, just to help people understand that in the future we'll get there. But I typically will block that for months until we get data in, people getting to see the value of visualization, getting the recommendations from the AIs or the code pilots or the ML models or just basic logic. And then at that point, when I've got confidence that this is built and architected and I've got others to audit my work, then I start thinking, well, let's just see if we automate this a little bit. And sometimes it's a lab and sometimes it's more. And that's why I say start at home. The home is the best place because you've got a partner in the house. And if the damn thing doesn't work, I guarantee you we have this thing that, and excuse me for being sexist, but we had this thing called wife acceptance factor when I started doing this 20-something years ago. Now it's, of course, partner acceptance factor. What it really means is when I push the button, the light comes on, then we get 100% acceptance. But if I push the button and nothing happens, somebody gets annoyed. I could use other words. But at least I can start to measure and kind of, oh, crap. Now, if that was an industry, oh crap, there's your P45, as we say in Ireland, your walking papers, you're done, you're messed up. So take them at the context they are, but it's easy enough to sort out as you go. But start with Home Assistant, work your way from there. And please reach out. My social skills are crap. My LinkedIn, I'm actually pretty damn good on, but my X's and the rest of those things, I'm sure Kevin will vouch for me. So if you really want to give me an X, ping Kevin and he'll ping me.
Absolutely.
No worries. Thanks a lot for joining. Learn lots on AI and IoT, and have to play with more automation at home.
We can hack in the next time and go deeper if there's an interest in the audience. I'm happy to dig in on the Home Assistant and bring it to the cloud, or I'm happy to go into the IoT. We have working environments here, and I'm happy to bring that to the cloud and do a little bit more practical. But I think this foundation stuff is really important before we get in here. Otherwise, everybody can, what the hell was that? Jesus, Damian.
Definitely do.
Thank you, guys, for the opportunity for boring everybody.
No, you're grand. So look, I want to say thank you very much to Manuel, and thank you very much to Damian for 2 really great sessions. As always, I always learn something from these. It's always really great, and I'll definitely be looking back at the recording on this video. Sorry to folks earlier, we had a couple of small technical issues. The link didn't work, the first one, but I think with over 40 live viewers, I think was pretty good comeback. So thanks everyone for hanging around.
Okay, and
thank you so much.
Thank you.
Thank you. Take care. Cheers.